Hi, imagine yourself on a vacation. Are you the kind of person who likes to plan your entire itinerary ahead of time? Or are you the kind of person who likes to make it up as you go? I'm sure you've been on lots of vacations with people, and whichever the kind you are, you're definitely annoyed by the other. And frustrating though it may be, it actually helps to have people who think differently. Because in the course of evolution, as circumstances change, it is likely advantageous to have a mixture of strategies and where one strategy is bound to succeed and the species survives. And I think our diversity and variance in decision making is what made us thrive as a species. But the mutations that cause these different strategies can also sometimes cause side effects and manifestations of mental illness, such as autism, schizophrenia, ADHD. So, in my research, I hope to understand how the brain employs different strategies and how it differs in different individuals, including those with mental illness. And how I do this, I do it using games. Now, games, as you know, are nothing but simulated environments where you can act and strategize to earn rewards and avoid punishments. And we, as the makers of the game, can control everything that happens in the game. And how do I go about my research? First, I start with a question. Do I want to understand how the brain performs algorithm A or algorithm B? And then I decide on the game which has the elements that can separate these two. And once I do that, I recruit participants to play the game while their brain is being scanned. Now that helps me record the people's choices in conjunction with their brain activity. So now when I see that a person A is making choices that are more in line with algorithm A, I also have their brain activity and can see which regions are facilitating this process. And now this helps me build a functional map of decision-making circuit that is employing algorithm A. Now, why is this useful? This kind of knowledge can have far-reaching implications because once we underpin the decision-making circuits in the brain, we can also see what happens when the decision-making circuits goes wrong or say in people with autism, schizophrenia, and people with other elements of neurodiversity. Now, this can help us build targeted therapeutic interventions like drugs that specifically target a region in the brain. And so my research not only helps us understand the origins of our intelligence, but it can also potentially help improve lives and thus enable us to embrace and cherish the diversity that has brought us so far down the evolutionary timeline. Thank you.